Okay, today is just a lazy Friday morning. It's raining, and I'm going to be upgrading some of my software products that I have. One in particular is a public safety product that I have that works on iOS, and basically it's using push notifications to send out. Basically, it works like a pager. The only exception is it also allows you to get audio. You can actually install something on a either a phone or a Mac OS computer, and basically run your audio from your radio, and it can detect the two-tone and almost like DVR functionality of that to the network over APNS, and it'll actually deliver it. So today, basically, the original design, I used the old style certificate with a server piece that sits on one of my servers that basically is PHP based that sends the APNS notifications. That's a little clunky, so today I'm going to be actually upgrading that. I'm just basically going to be talking about it. I'm not going to show a whole lot about it because I'm actually going to end up encoding my keys and stuff in the source code. So you probably won't see a lot of that up on the screen. But if you have any questions, be sure to stop by. Ask whatever you want, and it can be about any of the content on the channel, which covers a pretty broad base. But otherwise, I'm just going to get to it and kind of describe what I'm doing. Maybe this will help other developer out there. It's a fairly undocumented thing. I'm using VoIP technology, so I'm using a VoIP push, which is a little bit more difficult to do than just a normal standard APNS, and I'm using the Java Web Token key from Apple. And what that allows you to do is basically you can encode that into your app server side, so that you don't have to basically distribute your APNS keys. And it works pretty good. So basically, I've got a little software component that they install at the police station or the fire department or what have you. They hook it into the radio, and then they install the app on their phone, and they can now get their voice paging over their phone. It works pretty good, especially the VoIP APNS. It's really fast. It's low latency. It's pretty much instantaneous. And the main reason that I chose Go is initially I had that on the on one of my servers, as a PHP. There's also a Python library and several others. The thing I really like about Go is it actually produces an actual binary, so it's a little bit easier to use. I'm using the APNS2 library, and you're going to want to use the HTTP2 method of communicating. And if you look really close, I don't know that it was documented very well, but there is an option for actually loading your key not from just a file, but actually from like a variable. So basically, you want to create a variable that has all your file contents in it in your source code, and that way you don't have to distribute the key. It's basically going to be part of the binary. Now, I'm sure that could be extracted, this, that, and the other, but it's not something I'm really worried about. The keys are really easy to revoke if you ever have an issue at Apple, but I don't think it's something most of us are going to have to worry about. So to kind of get started here, I'm basically going to go in, and again, you're not going to see a whole lot of this. I'm kind of trying to pay attention to the chat, see if anybody shows up and asks a question. But so basically, you just want to get that APNS2 package installed for your Go library. The one thing that I'll say, and I actually didn't learn this till yesterday until I was working on another project, but in the APNS2 library, when you go to production, I think the example just basically does a new key token. You actually need to use the sub method of production to get that to work into production. That took a little while for me to figure out on another project I was working on. I just wanted to mention that because that's a key bit of information that probably was several hours of debugging trying to figure out what was actually occurring. So I'm just going to go, and the first thing you got to do is you got to generate a key, and that's going to give you, I believe it's a P8 file, and then I wrote another utility in Go that actually takes that file and turns it into a string, and then I'll actually put that in the code, and then that way the key is actually embedded into the executable when I get done. And I'm not doing anything super complicated on my APNS. The payload's really small. I'm not sending like audio or anything like that over APNS. I'm just basically sending a message to tell that app to wake up and go grab some stuff from the web server. I am using just standard MP3 files stored on a web server, so whenever there's an alert, it basically dumps an MP3. The only downside of doing that, and I may do something a little more advanced later, is you have to wait for the tone and the voice to end before you can actually deliver the message. So if you have a voice alert that's 3 minutes long, then you're not going to actually get that first notification until they down key the mic. Let's see. Okay, so now we've got our Go script configured. I downloaded the P8 file, converted that into a string, and plopped that in the Go section. And I've got this living out on a public server that's a test server. And I don't know if you've ever done any Apple development, but they actually test these things when you send them to the App Store. So not only do you have to debug and make sure that everything works, in this scenario, we have a server component too, which they don't test the server install, but they do expect one to be there so that they can exercise the app or what have you. So basically I'm pushing this out to that platform. I actually have two. One is production and the other is development. That way I can play around and not destroy what's running in production. Okay. Okay, that came through. So now that that works, now what I actually want to do is take this and actually put it with the app, which means that I'm going to do something really simple. I'm probably going to just pull up a UDP stream inside of Go. I'm going to be listening for a message. When that message comes in from the application, which is written in Swift, I will send it. And a lot of people have asked, why not just use Swift on everything? The main reason that I did not use Swift on this is there's not a pre-packaged example for APNS2 with Java Web Tokens with VoIP. And I'm not saying that the Go one is any better, but there is a little bit better documentation, a little bit better support. So that's basically why I'm doing it. And this one component, I can use it multiple places, even places that I don't have Swift. So I'm going to integrate that into the Swift component real quick. And this won't take long because I've already kind of prototyped it out. Okay, let's try this. Test. Okay. So that's basically, you know, a pretty big upgrade for how this is installed and how it works. The old way, they would download the app. The app would talk to something third party, which would be me, and then I would talk to Apple. Now the app literally talks straight to Apple. I don't need to sit in the middle, which I prefer. And again, this is only just signaling messages. It's not like, you know, their audio or what have you, even though it does go to a web server now. They do have the option of using their own web server. It really doesn't matter to me. But that APNS message was an issue, and this should solve it. Okay, I've already packaged up a binary, sent that to someone that can test that in real life on an actual system. And generally, I only have like 2 folks that have relatively small systems, and they're in some rural counties, and they're really good about, you know, installing it and letting me know whether there's a bug or not. And that's typically my production cycle. Is basically I test it. This particular change is fairly benign. I'm fairly familiar with it at this point. And I'll get that out to those 2, and if everything works for them, I'll put it in a general release. So it's not a super rigorous thing, and it's not a big deal, you know, for them to roll back or what have you. That's one thing. A lot of the customers that are not familiar with OS X are really happy with that it's so easy to go back and forth between application versions. And I've had similar experiences with you know, the DV modems that I built that are embedded off the STM32. People like boxes. People like boxes that you turn them on and they work. People like being able to, you know, drag an application into the trash, or even, you know, have 2 copies of the application running. So that's one thing that if you haven't gotten into it yet, obviously for products, embedded is the way to go, typically, rather than trying to do a software-only solution, especially on the PC platform, because it kind of just works. In lieu of that, you know, OS X, Linux to a degree. I've done a lot of Linux systems that are embedded type devices. The big issue with Linux is there's actually a fairly large curve to try to get, you know, something running on it, and make it reproducible and keep it up to date. You know, depending on what distro you pick, etc., you may lose long-term support. And there's only a couple of distributions that actually provide like a rolling release schedule, and even the rolling release schedules, you know, it's going to break things sometimes, especially if you're doing something custom. Okay, well, that project's done. Got that off. If I hear something back here in the next little bit, I will respond back. I apologize for the sniffles. Seems like this year I've had a cold or some kind of sickness about every 2 or 3 weeks. It's either been really cold here or really warm. I think today it's, you know, 66 and raining. Okay, it looks like they've got it. And it looks like they're going to test it sometime tonight. Okay, now to the next project. I don't know if you watch my channel. I think earlier in the week there was a Hackaday article on the STM8 project that I did. One of the things that I wanted to add to the STM8 project for the Razor is just a really quick. I've already got the CAN bus decode working for the water temperature. And basically what I'm going to do is just go in and I have one of those outputs that actually goes up onto my dash lights. And by dash lights I mean all the little, the switch bank for turning on and off things. I'm basically going to do an air condition. I'm going to add that real quick. And basically all that means is it's going to keep looking at CAN bus messages when the water temp, if it goes above a certain level. I don't really know what that is yet. I haven't really paid that close attention to see what the top is, but I'll probably look at like the service manual or something like that, see what their max, recommended temp is. I know generally it sits around 190, 195, something like that. But basically what I want to do is just prototype out a little addition to the software to basically flash those lights and warn me that something is awry. Because to my knowledge, there's nothing on the dash on Razor. You can scroll through the, I guess the RPM digital output and get to the temp, but it doesn't really, flash or tell you that bad things are about to happen. Not that I've ever had an issue, but I've seen guys have issues. It doesn't take a whole lot. You basically go to a big nut hole, get a bunch of dirt in your radiator, and then you're overheating. So I was just going to add that just for fun. And some of this I can show you. I'll have to be patient here, and I'll pull up a. I need to start with that CAN bus capture. And most things on the Razor are indeed standard. I know the gear selection is standard. Yeah, I don't know how much sense this will make, but let me just okay, I think I've got it here. So this is it. This is a really quick capture, and this is like my go-to. This is live data from my Razor. You can kind of see here, this is all the data, and these are standardized, basically looking at identifiers, and you're going to look for temperature, and on the Razor it is a standard CAN bus message for temp. You can dig online and look up any CAN bus decoder, and it'll actually show you what you got. So it looks like we do have some data here, quite a bit of data for the temperature. So basically I'm gonna use this test file, really utility that shows me values based off of the identifier. run this real quick. Okay, it looks like that worked. So now I've got test messages, and I know that this is going to work on a real CAN bus live stream. This is a data capture of the data, and I can run this in real time. So, let's see. Okay, so now we have our test data. We know we can pull out the right message. All we got to do is put that identifier in the CAN bus block in the STM8. And if you haven't seen that video, just look up STM8 on my channel. There's a whole series on this multiplexer, and that's one of the things. But this is just something I wanted to add. Still planning on going to Windrock at the end of next week. So I'm going to try to get this software in there sometime today. It's kind of rainy outside, so it may have to wait a day or two, but I want to go ahead and get the software change done. I'm just going to pull up the CAD schematic. I don't know which output that I actually use, but I know I put a note on the schematic for those lights. There's 4. So we're going to hijack 4 and do an alternate turn-on method for 4, which would be, blinky, 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 if an issue pops up. And this is all C. If you're not familiar with the STM, I'm using the SDCC compiler on Mac or Linux or Windows. But basically the SDCC is just a really simple toolkit for compiling for these small processors. And I've got a really simple makefile. Basically, all you do is build a project, hook an ST link to the STM8, and it programs. It's similar to the STM32. Most of my STM32 projects are actually Eclipse based, and I use the IDE. And you're also using the HAL libraries, which are okay. Most of them I've had to modify. One thing I wanted to mention on those HAL libraries, and this may help somebody else. Almost all of the HAL libraries are designed for fixed length messaging, and especially like UARTs. If you want to do something else other than fixed length, the easiest way to do it is to actually modify the HAL driver and add a function. And they may have already done this, but basically just modify it to where it's only doing 1 byte. That way you can do your own buffering. You can use a ring buffer. And basically you'll load it in. There's some exceptions. If you have something really fast and you need a DMA, you may want to do something different that'll actually look at the DMA message and continue to stack it. But that works really well if you can get by with just doing 1 byte at a time. That's where most people have trouble with variable length messages on a bus in the STM32. Those HAL libraries are designed to time out or get a fixed length. They don't do like arbitrary things, or they don't do them well. Firmware directory. Let's I'm going to add another scene here. Okay, so we've got our firmware directory loaded. And for the STM8, it's really simple. As you can see here, there's a make file. We have the standard library file there. And we've got a main C and an include file. And I'll just show you why I'm here. I actually think I'm in the wrong directory. I think I'm in the firmware for the RS-232/485 version of the STM8 project that I did. I have two versions. One is 485 driven bus, and the other is CAN bus. And the only difference in that is whether you're using a S or an A version of the STM. God, yeah, this is the 485. But anyway, this is the kind of what an STM8. If you notice here, there's no how calls or anything like that. There's not room for one on the STM8, especially the really small ones. The larger ones, they do have an STM8 library, but it's pretty much setting registers. Which isn't a big deal. Most folks are used to that, and the how usually gives them more trouble, especially if you started off with like an Arduino or something like that. And this is kind of what I was talking about the ring buffer. I use it pretty much everywhere in my embedded projects. So basically, it's just dumping data into the ring buffer, and if you're sending things that are not fixed length, you'll want to use a ring buffer, and you'll want to try to get your interrupt down to basically 1 byte. I actually have, I rewrite the function to be something like how whatever peripheral read, and then add the 1 byte to the function definition, and basically hard code it to where it's only getting a byte at a time. Okay. Okay, I've still got, probably going to need to stash these changes, so I'm not really going to dig into that project right now. I have what I need. Get back here and add this to my docs file, because the important thing is can we get the CAN bus message? Everything else is already coded. The inputs, outputs, already coded. The message is coming in on the CAN bus, confirm an event, and do whatever. And basically, I'll dump that into the timer, and I'll flash the lights. I don't know, a couple of times. There's something on the dash that's going to tell me that there's a problem. Okay. The version on this file so that I know what I haven't done and what I need to do. Okay. Let's see, I don't think anybody dropped in on chat. It's early morning, unplanned chat. And I plan on turning this into just a stored video anyway. You know, feel free to watch if not. Sometimes it's interesting just to see kind of what other people are doing, especially with software development. So I kind of just wanted to share some of the stuff that I do, and this is usually on the weekends I work on my projects, which is what I'm doing this morning. And those are the two things that I wanted to get done, especially before I leave next week to go ride. I've kind of got riding fever. I did a really short ride during the winter. We had, you know, a little bit of snow, and I got on the razor, and ever since then it's just been like, you know, you're wanting your weather to change and be able to get out in the woods, not just the razor riding, but camping as well. Tour hauler's just kind of been sitting there, not being used. Let's see if I just keep trying to take a peek over here, see if anybody drops in at the last moment. I'm going to try to keep these down to 30 minutes or so. One thing I wanted to say, I really do like the live stream, I guess. I don't know how well it works live, but it is pretty convenient because most of my videos, I don't do a whole lot of editing. So, you know, like it or hate it, I'm trying to, you know, get as much information out there as possible and not burn up a lot of time. Trying to, you know, make everything exactly perfect for retakes and that kind of thing. Not to say that I've never done a retake. I mean, I've done something and, you know, gotten a laughing fit or what have you and had to start all over. But generally, you know, if I drop a tool or something like that, I don't worry about it. But the live stream's kind of cool because you can just kind of sit there. It would be a lot more fun if you had a lot of people interested in it. But I think as far as interest goes, my channel is pretty wide base. And I usually don't know when I'm going to be able to do a live stream. This morning it's happened to be raining. I popped on. So if you do see this and you're interested in this, just I think there's a notification option that you can turn on if you're a subscriber to actually get, you know, basically a live stream notification. So if you want to ask a question or something, that's probably the best way to do it. I'll be happy to answer anything, you know, any of the topics that I've covered on YouTube. I'll do my best to answer. Okay, I'm going to close this one off. Thanks for watching, and I appreciate all the new subscribers, and we'll see you on the next one.